the two transversals, and we want to find the measure of BKM. So if I look, I've got BKM. So that's this angle right there. Okay. This transversal tells me, remember our checkerboard? This angle is the same as this angle. This angle is the same as that angle.
So that means that the angle B will be 32?
And those angles are the same. This angle, this green, all the green angles will be 32 degrees. Because this green angle is 32. We want to try to find the pink angle. How do we find the pink angle? Well, they make a straight line, right? This one's 32, so we're going to subtract from 180 to find that pink angle. Yeah. So BKM.
How did you get that was 32?
It's right here. It's small, but yeah. So basically, you get that checkerboard pattern. All the pink angles are the same. All the green angles are the same. So when we find this M angle here, we'll know this BKM, the angle we were looking for. So it's 148. Does that make sense? Okay. We come over here, same thing. These arrows are going to indicate that these lines are parallel. I'm going to have my true transversals, and I'm looking for MKJ, so I'm going to go MKJ. That's the angle I'm looking for right here. Want that one. Well, these will be the same, and these will be the same. Zoom in a little bit more. My pink angle here is 58, so to find the green angle,
Just subtract 180.
so 122. And so every pink angle is 122, or sorry, every pink angle is 58, every green angle is 122. So our answer is D. Triangle classification.
I think it's a right isosceles.
Yes, it is. This is one of the ones that will be on the final, because we covered that this term. Triangle classification.
So you let her know exactly what will be on the final from this. Okay.
So we have the two sides that
other
are the
ones
same.
more?
These were from term A.
Oh.
So these would be on end of course, but I'm not going to specifically test on this for the final. So if you have to take the end of course exam,
Oh, okay, okay.
but our final is only going to cover the second half. So
Okay.
these concepts though can show up in other things that we're doing, but I'm not specifically going to test on this for the final.
Okay.
But this will be specifically tested on the final, the classification of the triangles, because we covered that this term. So we have two sides that are the same, so it's an isosceles. We have a right angle, so right isosceles. Any questions on that one?
It's not scaling. That's scaling to two sides. Or is it two sides?
Isosceles.
So what's a scaling?
Scaling is when none of the sides match. Okay, so we have another triangle identification. We want to look at the largest angle here. Our largest angle is greater than 90, so we have our obtuse. Okay. Then we want to look at our side lengths.
Obtuse scaling.
Yeah, nothing is marked, so we can't assume anything
So
is
we
the
know
same
it's
size.
obtuse because it's open? Like a
Because
lot?
it's greater than 90.
Oh, okay.
Yeah, greater than 90. And we know it's scaling because none of the sides are labeled as being equal to each other. So we have that obtuse scaling.
That's another one that's going to be in the final.
Yes, this will be also on the final triangle classification. Just not gonna be very good. Okay, this is something from term A. We were talking about this. We have an end point, so this is end 1, and this is the midpoint. And we're trying to find the end point 2. So the midpoint formula is x1 plus x2 divided by 2, excuse me, y1 plus y2 divided by 2. Okay. End 1, first end point, is 25, negative 5. So I'm going to call this x1, y1. End 2, we don't know, so I'm going to call that x2, y2, because we don't know what those points are. And then our midpoint is here. Excuse me. I'm going to plug in the information that I have. Our midpoint is 18, negative 1. Our end 1, x1 is 25. I don't know x2. y1 is negative 5. I don't know y2. Okay, and now you might remember I showed 2 ways to solve this. So I'm going to show both ways again right now. So the first way is the algebraic way. We're going to use algebra, okay? So I'm going to take that. I'm going to take that setup that I have. This part equals 18. And this part equals negative 1. Okay. So the first thing I need to do to solve these is multiply by 2. Those will cancel. Bless you. I multiplied by 2 to cancel out the dividing by 2. And then 18 times 2 is 36. Then subtract the 25. So that's the x on the end point. Yeah.
So the algebraic way, is that like the easy way? Or is this just
It depends. For some people, the algebra is easier. For other people, the other method's easier. So that's why I'm going to show you both.
what was the first?
She hasn't done it
I
yet.
haven't done it yet. Oops, I forgot to multiply by 2. Multiply both sides by 2, so those cancel. I just rewrote it for some no apparent reason. So negative 5 plus y2 equals negative 2. Add 5 to both sides. And y2 is 3. So your end point is 11, 3. That's using the algebra to solve it. Back up a bit. Okay. And then method 2 is no algebra. And we're going to take our midpoint, multiply it by 2, and then subtract the end point. Okay, so that's step 1 and step 2. So my midpoint is 18, negative 1. I'm going to multiply that times 2. And I get 36, negative 2. Right, because I multiply both of those. And then I'm going to subtract the end point. And the end point we had was 25, negative 5. Okay. Now I have to distribute that negative, which makes this 36 minus 25 and negative 2 plus 5. negative 11, 3. Okay, so 2 methods. And you can pick the one that makes the most sense to you. This is not a final exam question. This is an end of course question. Yeah,
How come you multiplied that midpoint by 2?
if you look,
Because you have 2 missing variables,
because
right?
we're dividing by 2
Okay.
to find the midpoint, so you have to multiply by 2 to get away from the midpoint to find the other 8 points. If you, the midpoint formula divides by 2.
Right.
So to undo it, you have to multiply by 2. So essentially, this method here is exactly the same steps as this method here, just done without algebra. Because if you look, I multiply by 2 and then I subtract.
And then on the second part.
I multiplied by 2 and then I added, but the only reason I added was because this is a negative, and if I subtract the negative, it ends up being added.
Right.
So same thing, I subtract the negative and it ends up being added. So if you multiply by 2 and then subtract, it's the same steps as the algebra, just without the variables in there.
So for the other part, for the negative part right there, you
Distributed the
just
negative.
multiplied it.
I distributed the negative, so that made it minus 25 and plus 5.
Okay.
Does that make sense? Okay.
Gotta be a better way.
That's what I know how to use. Okay, so we talked about this one. Now we have endpoints, and we want to find length, and length is the distance formula. Okay, so we're going to want to plug these in to the distance formula in order to solve this. So I'm going to call this point x1, y1,
It's gonna be in the final.
x2, y2. No, this is just end of course. But it does show up in later classes, so it's good to have a review of it anyway. So we're plugging it into our distance formula. So I have x1 minus x2 squared, y1 minus y2 squared. x1 is 2, x2 is 18, y1 is 10, y2 is negative 18, and so I have to do that minus the negative. Don't forget that. Okay. And whenever we minus negative, that's a happy person, it becomes a positive. So 2 minus 18 is negative 16. 10 plus 18 is 28. Squared is 256. 28 squared is 784. Sorry, I don't know why I did that. Which is approximately 32.2490 and some other stuff. So we have 32.25 right here. Okay, we have a centroid. What statement is always correct about triangle ABC?
B.
Okay, well we have BO and OE, BO and OE. That's not true because the centroid is the 1 to 2 thing, right? So it can't be A. DF and AE are congruent. Have no idea. CD and BE are congruent. No. AE and EC are congruent. Yes. Because the centroid occurs on a median, and a median tells me that these two are the same length because this is a midpoint.
No, that's what was the definition of congruent?
The same length.
Oh,
Yeah, so congruent means the same length. So remember that a median on a triangle goes from the vertex to the midpoint, which tells me that these two are the same length, and that medians intersect at the centroid. Okay, so the only thing we know, if we know it's a centroid, I know that this length is half of that length. The side between the centroid and the side is half between the centroid and the vertex. And then I know that these two lengths will be the same because it hits a midpoint. Okay. Okay, so we had medians. Medians go from vertex to the midpoint. Okay. And altitude goes from vertex to other side at 90 degrees. Like that, and I don't know anything about those two lengths. All I know is that this is 90 degrees. A perpendicular bisector goes from a midpoint at 90 degrees. So it may or may not hit the vertex. If it hits the vertex, we're in an isosceles or equilateral triangle. If it doesn't hit the vertex, it's a scalene. Okay. And then we have the angle bisector that cuts the angle in half but it doesn't tell me anything about these two lengths here. So this length could be longer, this one could be longer. All I know is that these two angles are the same. Okay, does that help a little bit? Okay, all of the medians intersect at the centroid. All of the altitudes intersect at the orthocenter. The perpendicular bisectors intersect at the circumcenter, and the angle bisectors intersect at the incenter. And I will make another piece of paper with those properties. I'm just recording silence. That's kind of silly. If we have our centroid, the length from the centroid to the vertex is 2 times the size from the centroid to the side. And the whole thing together is 3x. So we have basically 3 parts. This is 2 of them. That's 1 of them. Okay. The orthocenter, there's nothing. It doesn't do anything. It's just that's just what you call the point. It doesn't have anything special. With the circumcenter, that's from the perpendicular bisectors. I should probably do. That's the bisectors. And then if you go from the circumcenter to the vertices, these lines are the same length. Okay. With the incenter, all of the angles are cut in half. That's the angle bisectors. And then these lines are the same length. So if you bisect the sides, you get lines to the angle that are the same. If you bisect the angle, you get lines to the side that are the same. So we just kind of went over this. The circumcenter, so which segment passes through point O for all the lengths of the sides of the triangle? Circumcenter are the perpendicular bisectors. So the perpendicular bisector side AB will pass through that point.
Huh?
Circumcenters are where the perpendicular bisectors intersect.
So it's not C.
No, because a line segment drawn from C through O is not perpendicular to AB. We don't know that for sure. Perpendicular bisectors don't always hit the vertex, right? So we know that it has to go perpendicular to AB through O. I just don't know where it'll hit the other side. So I can't say from C. Does that make sense?
But it can't be from C because
Because this won't be perpendicular. Do you see that angle is not a 90 degree, right?
so how would you do the perpendicular bisector side?
You'd have to find the midpoint, and then you'd have to take a protractor to find the 90 degree angle and then draw it. But you're not going to be required to do that on the test.
That's gonna be on the final.
This will be something like this on the final, yeah. Does that make sense, though, why it can't be C? It has to be perpendicular. If it says circumcenter, you're talking about perpendicular bisectors of the sides. Okay, number 9, this is the triangle inequality theorem.
This was not term B, right?
Yeah, this is. We just did this. This is the one that tells me that the length of the side has to be longer. Remember, we have any two sides, when you add the two sides together, have to be longer than the third side. So remember when I told you how to find this? I said add them and then subtract them. So we have to do 19.5 plus 12 and then 19.5 minus 12. Okay, so the shortest it could be is 7.5. And the longest it can be is 31.5. Okay. So we have to look at this and we say, okay, what is not a possible length? Well, 7.5 is the shortest. This is only 7, so it can't be 7. It has to be at least 7.5. So A. Does that make sense? This is the shortest it can be, so it can't be 7. Any questions on that one?
Okay, so
Okay. All right, she's trying to buy a home and the plot of land is a triangle. She would like to have a long property line across the street. So this is the street. Okay. because angle M is opposite the roadside. And she wants to have this to be the longest. These are the possible angle measures. Which one is going to give her the longest property line?
103?
Yeah, 103. Because the bigger the angle, right, the bigger it opens up. Remember, the bigger the angle opens up, the longer that other side is. The bigger the angle, the bigger the side across from it. Remember when I showed you the compasses opening up? That's like that. So
Then you would just assume it was
no, it's not just that. Those are our choices, and that's the biggest angle, so that's going to give us the longest side. Does that make sense? Are you sure? Hold on.
Show me an example.
We have?
Yeah. When we were talking about our side angle side and angle side angle, okay, so I have a side, two sides that are congruent, right? So I have the 120 and the 120, those will be the same. BC is the same as itself, so I have a side angle side that tells me these two triangles are congruent,
You
right?
put them all.
Okay. So remember, for our triangle congruence, we can have side, angle, angle, side, angle, side, 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 angle, angle, side.
An angle side, I'm sorry.
We cannot
I'm just
have,
kidding.
yes, we cannot have angle, side, side.
Or side angle.
Well, side angle, angle, you just flip it around, that's okay. Okay, so these are the ones we can use, and then I have side, angle, side, so that means that the third sides are gonna also end up being the same length. So if this is 160, this one's also 160. Okay. Any questions on that one? Okay. Now, we did not get to this yet, unfortunately, but this is going to be something that's on the test.
Is it B?
On the test or
Or
what?
on the, no, on the end of course. This is,
Just affect 180 and then
well, okay, similar triangles are in proportion to each other. So they have same angles, but different side lengths. And you should have some proportions from the different side lengths are proportional. And you should have had some proportions in Algebra 1. Okay, so what we do with this, I'll zoom out just a little bit. Okay, I have to figure out which sides match. Okay, so I have the 75 to 45 is MN. 75 to 45 is PQ. These two sides will be in proportion. Because you see how all the angles match? And so the sides between the matching angles will have a relationship between them. I have 75 to 60, 75 to 60, so those two sides will be in proportion, and then the final sides will be in proportion. Now, if you look at this, 42 and 28, and then 33 and question mark. Does everybody follow so far? So the 28 and the 42 go together, and the 33 and the question mark go together. So what you want to do is, if you put the small over top of the big, like so the small triangle over top of the big triangle, if you always remember to put the small number over top of the bigger number, it keeps them, because you have to keep them in the same, like I have to do small over big, or big over small, big over small. I have to keep them the same. If you always do the small on top, you won't ever make the mistake of flipping one of them and getting the wrong answer. And it's sort of logical to put the smaller one on top, right? You know, if you're like, you remember cheerleaders and build a pyramid, you never put the biggest, heaviest cheerleaders on top. You put the little tiny cheerleaders on top, right? Small goes on top of me. Okay, so 28 is going to go over 42. The sides that go together go in one fraction. And then I don't know what this is, so I'm going to call it x goes over 33.
But wouldn't it be smaller?
X is smaller than 33 because 28 was smaller than 42. So x goes on top of 33.
Oh, okay, I see it.
So far, okay? So the red sides, the green sides, you set them equal to each other, and then you're going to cross multiply. So 42 times x is equal to 28 times 33. So 28 times 33, anybody memorized your 33s?
Not 22.
Oh, good job.
Were we supposed to?
No, you're not supposed to memorize your 33s. It's
And
okay.
divide
Divide by 42. And x is going to be 22. So that's that missing side. Oops, I cut myself off. Okay, so this is not going to be on our final, but stuff like this will show up on the end of course. And you just set the matching sides. So like this, the red sides in one fraction, the green sides in the other fraction. Make sure you do small over big and then cross multiply. Sabers. So we're talking about proportion. So if I have the 33 and the 11 are both the blade of the lightsaber, so those go into, and then the 9 and the X, like that. So I get 99 is equal to 33x or vice versa. Divide by 33, and x will be 3 inches. So the handle of the small lightsaber will be 3 inches.
Can't you just look at that and say, hey, everything's equal by 3?
Yes, you can. But if you can't see it, I want you to know how to do it. Does that make sense? Because sometimes, yes, you can look at them and you can be like, oh, if I multiply this by 5, it's 5 times bigger. And sometimes it works out that way. But 28 to 42 is a fractional larger, and so it doesn't, you can't always see it. So, but yes, if you see that this is divided by 3, you can divide that by 3. Or if this is multiplied by 3, you can, vice versa. Absolutely. You cut a triangle and you get parallel lines like this, you create 2 proportional triangles. So this small triangle is going to be proportional to this big triangle. Okay.
Which is the same, but this is smaller.
Yeah, so this whole length is 22.
So then that little length.
And this whole length is 22 plus x. So this one's going to be a little bit more complicated. So to find the length of the big triangle, I add the 2 small parts together, right? Well, if I add these 2 small parts together, I don't know that one, so it's 22 plus x. So still, though, I'm going to set up a proportion, small triangle, large triangle. So I'm going to have 4 over 18 for the small to, not 18, sorry, 22. I'm lying to you, don't mean to. 4 over 22 for the small triangle to the big triangle. And over here I have to have x over 22 plus x.
Why 20?
Small, big.
Uh-huh. Well, why x?
Because
After
that was
22.
x. The whole length of the big triangle is
Okay.
both. Does that make sense?
Uh-huh.
So then when I cross multiply this, I get 22x is equal to 4 times 22 plus x. So 88 plus 4x. So far okay? Subtract the 4x from both sides, and I get 18x is equal to 88. So x is equal to 4.9. Where'd I lose you?
Where, I'm just trying to catch. Verse 18.
So we look at this. We have the name, and then there's two properties. One is all interior angles are equal, and the other property is unknown. And then we look at, we have a square and a rectangle. Square has whatever this unknown property is, and all interior angles are equal, and the rectangle doesn't have it. Well, what's the only difference between a square and a rectangle?
Sides.
Side lengths, right? So all sides equal for square, not for rectangle. Make sense? Number 20. Knocked over my markers. Okay, we have some figures. We have, which statement is true? Shapes 1 and 3 are kites if their diagonals intersect at right angles. That's true. Shape 2 and 4 are trapezoids. No. Trapezoids don't have parallel sides. Two pairs. Trapezoids only have one pair of parallel sides, right? This is a trapezoid. This is not. All shapes are parallelograms if they have 4 sides and 1 pair of parallel sides. No. And shapes 1, 2, and 3 are parallelograms if they have 2 pairs of sides the same length. No. The only one that's true was A. And kites have diagonals that intersect at right angles. So you have a kite. These are the diagonals. Those will be right angles. Remember that? Vaguely.
19 and 20 are going to be on the final, right?
19 and 20 will not be on the final, but they would be on the end, of course. This was term A stuff. Okay. The major difference between a square and a rectangle: squares have 4 equal sides. Rectangles have 2 pairs of equal opposite sides. True. That's the major difference, right? With a rectangle, you get 2 sides that are the same, and then 2 other sides that are the same. With squares, they're all the same. Okay. Comparing a trapezoid and a kite. Okay, so we have a trapezoid and a kite. Okay.
What?
Trapezoid.
Begin
Oh, sorry. Trapezoid and a kite. So, trapezoids and kites do not have, trapezoids have congruent diagonals, but kites don't. So that's not going to work. Trapezoids have 1 set of parallel sides, but kites don't.
Okay.
They don't have congruent sides. The only comparison you can make between a trapezoid and a kite is they both have 4 sides. So far, okay?
What was it?
They both have 4 sides. Yeah. They are both quadrilaterals. Okay, we have a square. This is one of those graphic type of things. So,
Which number?
23.
23.
Okay, so I'm going to I have -3, 5. I have 1, 7.
And 3.
I have 3, 3. And then some unknown here, right? Well, to go from 7 to 5. Oh, wow, I made that way too high, I think. 1, 2, 3, 4, 5, 6, 7. Yeah, that should be here, not there. Go from 7 to 5, I go down 2. And then to go from 1 to -3, I go over 4. So far, okay? Makes sense? I'm going from one point to another point. If I do the same thing here, I go down 2 and over 4. I was at 3. If I go down 2, I'm at 1. And then if I go over 4, I was at 3. I'm at -1. So it's going to be 1, -1. Because the squares, all the sides are the same length, right? So if you were to make a triangle between the points, of a square, the triangles should match. So if I go down 2 over 4 and I go down 2 over 4, I'll find that fourth corner of the square. So if I go down 2 from 3, I'm at 1. Sorry, negative 1, positive. Yeah, I wrote it backwards. I'm at 1, and then if I go backwards, I'm at negative 1. So the x is negative 1, the y is 1. Okay, so we're going to stop there for now.